Good day, listeners at home. So we are given a question of projectile motion, that is a bird traveling at 50 meters per second wants to hit a man 100 meters below with a dropping. How far a distance before flying directly over the man should the bird release it? Now we have a bird, but first and foremost, so what we need to understand is that, like I said in my previous video, so before you can put on solving any question on projectile or in any topic, you must have good knowledge of the concept. So without good knowledge of the concept, one may not be able to solve this particular question on projectile. Now we have a bird. A bird is traveling at 50 meters per second. That is, horizontal component of velocity is given to be 50 meters per second. Then we have the path that the bird will take. Then we are given the vertical distance between the bird and the man on the horizontal ground. We have the man on the horizontal ground here. Then the vertical distance is given to be 100 meters. Now, and the bird traveling at 50 meters per second is to drop something. So, and the question is, how far in distance before flying directly over the man should the bird release it? Now, that is what the bird is to drop here. If is to hit the man on the horizontal ground at a distance of 100 meters below it. So how far in distance before flying directly over the man should the bird release it? Now, according to Sir Isaac Newton, so the equation of motion, there are 4 equations of motion. The first, we have S equals to U plus V divided by 2 times T. The second, we have V equals to U plus AT. The third, S equals to UT plus 1 over 2AT squared. And the fourth, V squared equals to U squared plus 2AS. Now, what we are going to do now is, by considering the second equation of motion here, that is V equals to U plus AT, we want to derive the formula for solving the time taken to reach the maximum height. Because we have to consider the question as if the object will move from this horizontal ground to this height. This will serve as the maximum height. So with given initial velocity, which is u of x, u of y, because it's vertical component, u of y is moving vertically upward. So at this particular point in time, we have phi of y, which is the final vertical component of velocity. At this maximum height, the point at which the object projected vertically upward return back to the ground. So at h maximum, so the final velocity, that is final vertical component of velocity, return to 0. So now we have phi to be 0 using this formula. Now for upward motion, we have g to be negative. Upward motion, g is negative. We have negative value of g. So this equation turns to phi final, that is phi of y equals to u of y minus gt, vertical component. We want to determine the time taken to reach the maximum height here. Now, at maximum height, final vertical component of velocity equal to 0. We have 0 here equals to, we have 0 equals to u of y minus gt. We are making t the substitute of formula. By taking this minus gt to this side, we have gt equals to u of y divided both sides by g. This cancel this. We have t equals to u of y divided by g. So this is the time taken to reach the maximum height. Now we are going to consider this formula. This formula, which is the third equation of motion. That is, we have S equals to ut plus 1 over 2at squared. Now for upward motion, that is vertical displacement, we have this here will turn to h equals to u will be u of y multiplied by t minus, because g is negative for upward motion, 1 over 2 gt squared. Now don't forget the time taken is equals to u over g. So that is, let's make uy the subject of formula here, so that we can, because we are determining the time. So u of y will serve as the object of the formula. That is, it should be u of y here. That is u of y. So when you take gt to this side, we have gt here equals to u of y. That is, in place of u of y, we can substitute gt there. Then h equals to gt times t multiplied by t minus 1 over 2 gt squared. So we have h equals to, we have gt squared minus 1 over 2 gt squared. Now, we are going to take half from 1. When you take away half from 1, you are going to have 1 over 2 gt squared. Now, with this given vertical displacement, which is 100 meters, we can determine the time taken. Because if you take the same time for the object to move from here to here and to move from here to here, it will take the same time. So therefore, with this given height, so we want to determine the time taken. For the time taken, so we have h is given to be 100 meters. So we have h, which is equal to 100 meters. Then we have g equal to 10 meters per second square, Then we want to determine time is unknown. Then we are going to substitute into this formula. We have 100 equals to 1 over 2 by 10 times t squared. So 2 goes in 10, we have 5. That is 5t squared. Divide both sides by 5 by 5. This cancels this. So therefore, t squared equals to 20, which implies t equals to square root of 20. In some form, it will be 2 root 5 seconds. So that is the time taken. That is the time taking the object to move from this horizontal ground to this height is the same time it will take the object to move from here to here. So therefore, the time taken is 2 root 5 seconds. We want to determine the horizontal distance. We are going to consider this formula. So we have s equals to ut plus 1 over 2at squared. So we consider it on the horizontal because it's mostly under gravity. Therefore, this will turn to r, the horizontal distance, that is horizontal displacement. So r equals to u of s times t, the time taken to move from here to here, then plus 1 over 2 gt squared. But for horizontal motion, this g has no effect, it's turned to 0. So g will be equal to 0. We have r equals to u of s times t, and u of s is given to be 50 meters per second. Therefore, r equals to 50 multiplied by t is now equals to 2 root 5. That's what we got when we calculate the time taken. So 50 times 2 will give us 100, that is root 5 meters. And this is the required distance. Please like, share, comment. You are blessed. Thank you.